All right, so I think this is page 47, and these are those day one problems that we had done, 47 to 50. Okay, so this first one, it was a geometric because it wanted the first miss on the 5th spot, so there you got that. And this second one had the first making it on the 4th spot. So because it put those in a particular place, those are your geometrics. Now, I want to go ahead and talk to you about statement C. Problems like this statement C are similar to the most missed question on the probability test. So let's talk through this. So this says he makes his first basket. So it's placing where he got his first basket. And the spot that he gets his first basket is either is one of the first 3 shots. So he's getting it on the first shot that he makes, or he's getting it on the second shot that he makes, or he's getting it on the 3rd shot that he makes. So this essentially is putting that first shot in, is doing geometric of it being in the first place, geometric of the second, plus geometric of the 3rd. Okay, so that's the language that means to do that. Let me read it again. He makes his first basket, so the first time he's successful is one of the first 3 shots. All right, number 8, this one was geometric. It put the first bad chip that you come to as that 5th. And so then let's talk through these other ones. Statement B says this. What's the probability that you find a bad one within the first 10 you examine? So when it talks about finding a bad one, it's finding at least one of those 10 are bad. And so remember from chapter 14, the probability of at least one is what? 1 minus the probability that none of the 10 are bad. Okay? All right. And by the way, it is doing all of the arrangements except for the one where none of the 10 are bad. So that is a binomial. When it does that, 1 minus the probability of none, it's doing all of the arrangements, all of the various combinations except for that one particular one. Okay. Number 8, or number 9, I guess, says, what is the expected number of shots until he misses? Well, these ones that ask how many do you expect, how many are you going to go until you get one, that's the new thing that we're going to learn today, later, at the end of class, on page 46 in your notes. So let's save those problems for later. Okay, moving on to the next page, page 11. So this problem wasn't done at all, but let's talk through it because I'm wanting to let's go through the translation of the language. So here we go. Only 4% of people have type AB blood. So that's what this problem is about. A says, on average, how many donors must be checked to find someone with type AB blood? That's going to go, on average, how many do you expect to have to pick until you get one? That, again, is something we're learning later. How many do you expect? So skip part A until later. B, what's the probability that there is a type AB donor among the first 5 you check? So how do you translate this? There is a type AB donor. At least one. Very good. So this is one that says there's at least one amongst the 5. Okay? And so then, of course, that's your 1 minus the probability of none. All right, part C. And I actually did this one incorrectly earlier in the day because I skimmed over this word here. So let's read it very carefully. Here we go. What is the probability that the first type AB donor that you come to is one of the first 6 people? So that is telling you they want the placement of that first AB donor to be where? Any one of those first 6 people. So that's basically saying it wants geometric of 1 plus geometric of 2, the success on the second one, and then all the way up to geometric of 6. So that would, if you were to really write that out with numbers, it would look like the first one is an AB donor plus the second one is an AB donor plus the third one is the first one, and then the fourth one is the first one. You get the idea? Then the fifth one's the first one, and then the sixth one is the first one. So again, this is the key. The first type AB donor you come to, okay, so that's the key that makes that one so special there. All right. So next one, number 11D. What's the probability that we won't find a type AB donor before the 10th? This one, see, there's such subtle, tricky wording. So let's read that again. We won't find one before the 10th. So before the 10th means I don't tell you what happens on the 10th person. So we don't get, or we don't know what the 10th person is. We just know that the first 9 people are going to what? Not be type AB. Good. We know that the first 9 are not type AB. So let's read that again. What's the probability that we won't find the type AB donor in those 9 before the 10th? Okay, number 12. This is the colorblind male, so you can check those 2 that you did, B and C. This A is one that we're going to learn later today, so we'll skip it. On average, how many do you expect to check to find one? Okay, that's one of those types we're going to learn later. And let's look at D. What's the probability that she finds someone who is colorblind before checking that 10th person? Before checking the 10th person. So that means that you have what? You find someone. What's that mean? You find someone. There's at least one. Before checking that 10th. So there's at least one amongst how many? Good. There's at least one amongst the first 9 men. Okay, and again, you know, when we do probability of at least one is 1 minus the probability that none of the 9 are colorblind. All right, and then I just kind of leave it at that. You'll finish these out tonight. Okay, moving on to 13. 13 was also stating that the first one you come to is the 5th spot. So that's your geometric. Look at B, that's the one you'll do tonight. There are some lefties among the 5 people. There's at least one. Okay, it says it there. Look at part C. The first, this is just like, in fact, this is more like the most missed question on the test than the ones I've already talked to you about. This is so close. Listen up. This says this. The first lefty is the second or the third person. So here is the number one way that people did this problem, but it's wrong. The way people did this on the test is they said that that's not a lefty, but it's the second one or it's the third one. That's the way people did this on the test, and of course that answer was one of the multiple choice answers. But this is wrong. You have to say the first one you come to is in the second spot, or the first one you come to is in the third spot. Okay? So just really watch out for those. you're doing geometric for the second spot plus geometric for the third spot. Okay. Now D is really the first binomial one, like the new stuff we learned yesterday that you come to. Exactly 3 amongst the 5 are lefties. That means those 3 can be sprinkled anywhere. Now let's look at the work you had to show. Let's make sure you showed the proper work. The probability that x equals 3, okay, is, what does this 5 over 3 mean? 5 choose 3. Very good. That is not a fraction. That's how many combinations you have. That happens to be the number 10. Not that you needed to calculate that. And then there are 3 lefties, and that means there is 2 righties. Now, check your answer. If all you did was multiply these 2 things together, then you got 0.001663. But there's 10 combinations of that. So the calculator would have multiplied that by 10 to get the answer there. Which, by the way, the keystrokes you would have put into the calculator would have been 5 trials, probability of 0.13, and 3 successes. All right. Now, these next 2 are really, I'm going to go over these with you, and they're going to be a lead-in. They're going to be a good introduction. They're going to cut off some of the stuff we'll have to teach you tomorrow, okay? So this is kind of a precursor to tomorrow's lesson. So let's take a look at this. There are at least 3 lefties in the group of 5. So if there's at least 3 lefties, how many can there be? There can be 5. There could be 4. And there could be 3. Good. There could be 3, 4, or 5. So that means, and those 3 could be sprinkled anywhere. They could be arranged in any order. And those 4 could be arranged in any order. And of course, 5, all 5 would be that. So here's what that is. You're really saying, I need a binomial of 3 successes plus binomial of 4 successes plus binomial of 5 successes. Okay? Now, that could be a whole heck of a lot of formulas that you have to write out. Oh my gosh, you'd have to write out that freaking formula 3 times, and sometimes you have to do it even more than that. However, I'm going to tell you the shortcut. Here's how you do it. When you have a sequence of formulas that you have to write out, you only have to do the first one and then the last one. And you just put ... in the middle. So the ... represents any of them that are in between the first and the last in that sequence. Okay, so let me show you what I mean here. So first, so let's write this, let's get you practiced on writing this work. Here we go. The probability that x is at least, so that's greater than or equal to 3. Okay. So let's do the first in our sequence. It's how many successes? 3. So my 5 choose 3 combinations. And I got 3 lefties, which means how many of them are righties? 2. Okay, very good. Plus ... plus, and that takes up anything in the middle. In this case, I have just one formula, but you could have 20 things in the middle, and you could write that. Now I'm going to do the last one in the sequence, which the last one in the sequence is how many successes? 5. Good. So that's 5 choose 5, and 5 of them are lefties, and 0 of them are righties. Okay. Very good. Now, calculator-wise, what you would have to do is go and do this in your calculator and figure out that number and add it to this one in your calculator and figure out that number and add it to this one in your calculator. Okay? I'm going to show you a calculator shortcut tomorrow, but for today, I want you to just add those 3 binomials from your calculator together. All right, and that's what you'll do tonight. Questions there? Okay, let's practice one more of those. Here's the next one. There are no more than 3 lefties in that group of 5. No more than 3 lefties in that group of 5. So that always messes with my brain. No more than 3. So how much can there be? 3, 2, 1, and 0. Just not more than 3. Not the 4s and not the 5s. So here's what it could be. It could be the binomial of the 0s plus the binomial of the 1s plus the binomial of the 2s plus the binomial of the 3s. So calculator-wise, you have to do all 4 of those numbers and then add them together. Okay? But let's practice the work. Here we go. Probability that x is what? Very good. Less than or equal to 3. Okay. Now I just have to do the first one in my sequence. The first one in my sequence is going to be how many successes? 0 successes. So it's going to be 5, choose 0 successes. So that's 0 lefties, which is 5 righties, plus dot, 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 plus, so I can leave everything else in the middle. And what's going to be my top one in the sequence?
5, choose 3.
5, choose 3. 5, choose 3 successes, which is 3 lefties and 2 righties. And then go to your calculator and figure out those 4 binomials and add them all together. Okay? And again, I'm not going to make you do any more than that, more than 4, because I'll show you a shortcut tomorrow. Yes, ma'am.
Okay, so when we were putting it into the calculator, like the 5, choose 5 one, you would put 5,
5 trials,
and then
point 13,
and then 5 again.
and then 5 again. Yep.
It gave me like some weird numbers.
It's really teeny tiny small. It's like 0.0000 something because it's really small. It's in scientific notation.
Is that the CDF?
No. Oh, tomorrow we're going to learn about the CDF, but not today. Today you're still doing PDFs. So you're right, Izzy. That one for the 5, choose 5, it's really small number. You're going to have to do your scientific notation, move your decimal and stuff, okay? All right. Now, guys, these next 2 problems, 15 and 17, are all the stuff we're going to learn new here in a little bit. So let's move on to the next page. Turn on over to the next page. This is about lefties again, but it is out of 12 people instead of 5. So we're out of 12 now instead of 5 people, and so let's see how that changes things. Here we go. So you were supposed to have done this problem last night, so check and see how you did. What's the probability that they are not all right-handed? Okay, so if I look at 12 of you and you are not all right-handed, what does that mean? At least one of you is left-handed. Good. And if at least one of you is left-handed, then that's 1 minus the probability that none of the 12 are left-handed, which is 12 righties. Okay, so that's the work on that. Now, see, my brain is kind of just like slow in that way. I have to go through all those steps. But I had somebody yesterday, and this is the first time somebody's told, explained this to me, and I thought, yeah, I like that. That's a short way to do it. Here's what he said. See if you like this way better. He said, hey, the probability that they are not all right-handed. So I took not all right-handed, and not all right-handed means 12 right-handed, but not that. So that's 1 minus the 12 right-handers. Anyway, there's another way you could think of it. So I don't know if that jives with your brain, but that's what he liked, and it was a heck of a lot shorter than the way I had to think of it. So I'll say it again. Not all right-handed. So he took all the right-handed ones, and he subtracted it from 1, so it's not that. Anyway, I liked it. I thought that was good. Okay, how about this one? Let's talk about how you're going to handle this one tonight. What's the probability that there are no more than 10 righties. No more than 10. So as long as there's not 11 or 12. So what can there be? 0 to 10. Okay, so there can be the successes, and this is a binomial, can be from 0 to 10. 0 to 10 successes, and this is binomial. Oh, but you know what, though? This is talking about righties. Righties. So let's see. Why don't you practice the work on that and see how you would do? See if you could figure that out. Because it's about righties, not lefties. So the first in my sequence has how many righties?
0.
Okay, so that's going to be 12, choose 0, and there are 0 righties. So make sure the percent you put here is 0.87 to the 0, which is 0.13 lefties, 12 lefties. Okay, so let me let you think of that real quick. This is the first part of the sequence, and that is 0 righties, because this problem is about righties. Okay, so what's the last in the sequence going to be? 12, choose 10 righties. So my percent is 0.87 because that's the righties percent. And then how many lefties would there be in that case? 2. Good. Now, mathematically, what would you have to do? Oh my God, you have to do binomial of 0 plus binomial of 1 plus binomial of 2 plus binomial of 3 all the way up to 10. So on these ones, I'm going to teach you the shortcut tomorrow so you can omit the calculations on this one. How's that? You can omit the calculations on that one, and we'll also be doing that on the D, part D. Okay, let's look at the other one you had for homework last night. Statement D says, what's the probability that there are exactly 6 of each? So, that is 6 righties or 6 lefties, whichever way you did that. That is a binomial. Exactly 6 out of the 12. And so let's look at E. This one you do tonight, so let's discuss. What's the probability that the majority are right-handed? Okay, what's majority? Over half. And what's over half of 12? 7, 8, 9, 10, 11, and 12. So that means, so you can omit the calculations on this, but I do want the work. But show your work, which is x's are greater than or equal to 7, and then finish that out for homework. Okay, so there we go. So I've walked you through the rest of those. I hope that that's helped you kind of get a handle on some of the translations of the data. So I want to teach you one little thing on the notes. And so if you will turn to page 46, I'm going to show you, we're going to go through those notes. Okay, so here we go. This is on page 46. All right, so this is kind of the new thing of the day. It's not very long, so let's talk about it. It is all about how many do you expect? That's the goal today. How many do you expect? Well, you determine it differently based on if it's geometric or binomial. And so let's look at these formulas here. Yesterday we did this formula. You know, we're familiar with that. That's your successes and stuff. And these two right here are for binomial problems. In fact, all of these are for binomial problems. All of these formulas are for binomial. This one is, see that letter mu? What have we represented with the letter mu before? Mean, good. This is how many, on average, that you expect to find. That's how many on average. That's why it's represented by the letter mu. Okay, and then with this standard deviation. So this is the formula. That's the standard deviation. So that means how much your sample might be different from my sample and all that kind of thing. All right, so let's practice some of those. Now, I want to remind you that we will have binomial problems if it is out of a set number of trials. For example, this problem is out of, how many would you expect out of the first 10? See, that's your set number of cars. So out of the first 10, that's what indicates to you that I'm going to be doing binomial. So this is how you knew we were going to do binomial. Now, there's something wrong with this problem. It doesn't tell you what you're looking for, so let's have a little discussion. So if I ask you how many drivers would you expect, don't just say to count. Let's say to wear a seatbelt. Will you put that in there? That's a mistake I have in the notes. How many would you expect to wear a seatbelt? And let's recall, yesterday we had a problem where the probability of wearing your seatbelt was 0.75. Okay. So let's do this. So how many, if you looked at 10 cars, how many would you expect to be wearing their seatbelt? So on average, that's N times P. So I would expect, what's my N? That is your 10. That's your number of cars that you're looking at. And what's the P? The 0.75, the probability of what you're looking for. So that's 7.5. What in the world? I have a question. How can you look at 10 cars and find 7.5 of them wearing a seatbelt? What? No, not because there's 2 people in the car. Guess what this is? It is an A on average. That means Tyler looks at 10 people and he found 8 of them wearing their seatbelt. Okay? Kyle looks at 10 people and he found 6 of them wearing their seatbelt. Okay? Avery looked at it and she found all 10 of them wearing their seatbelt. Okay, but on average, if I averaged everybody's sets together, it would average 7.5 people wearing their seatbelt. Okay, with what standard deviation? Well, let's do the formula. Standard deviation is the formula square root of N P 1 minus P. So let's fill that in for this. What's N? And P is 0.75. And what's the 1 minus P? That's that 0.25. This comes out to 1.37. So I want you to think in terms of outliers and stuff. On average, when you go get your 10 people, when you go look at your 10 cars, you should find somewhere around 7.5. But if you're more than 2 of these standard deviations above or below, then you have a freaky sample. Okay, you see, this kind of tells me how close should the samples be to 7.5. That gives me an indication. All right, moving on. Here we go. Last new thing to learn, and then we'll go practice some on the assignment. If I asked you, how many cars would you expect to count until I find a driver that is, by the way, we're talking about not wearing a seatbelt on this one. I'm going until I find one. Did I tell you how many cars to look at?
Nope.
No, I did not give you a set number of cars to look at. I just said, hey, how many are you going to have to look at until you find one? And so that's what makes it geometric. This is not on the formula chart. This is one that you have to know, and we'll review it again before the AP test and everything. So this one's not on the formula chart. So the average or the expected for geometric is 1 over the probability that you're of the event you're trying to find. So in this case, 1 out of the 25% that do not wear a seatbelt, so 1 over 0.25, and that comes out to 4. So on average, I'm going to have to look at 4 cars to find one that doesn't have a seatbelt on. Okay? Now, Matt, it might be the very first car he looks at. That person is not wearing a seatbelt. Okay? But Sarah might get to go all the way to the 10th car before she finds somebody not wearing a seatbelt. But on average, when I average those results together, what's it going to come to? 4. Okay, yes, sir.
On the one above that,
Uh-huh.
I don't know whether to do the standard deviation.
Oh, I just went ahead and did it. Usually it'll say, and with what standard deviation. Yeah. I went ahead and did it just so we could practice. Okay, very good, guys. So now let's practice this in the homework. How's that? Go to page 49 in your assignment. So up here, page 49, problem number 15. Page 49, problem number 15. All right, this one says, consider our group of 5 people where 13% are lefties, okay? Oh, so this is out of 5 people. What does that mean it's going to be?
5, choose X.
Okay, but I'm telling you a set number of people to look at. So is that going to be binomial or is that going to be geometric? Binomial, because I'm telling you a set number of people to look at. So this will be binomial. All right, how many lefties do you expect to find out of those 5? There's a formula for that. What is it? Nope, the average of how many you expect is n times p. So that means out of the 5, I expect 13% to be lefties, and I don't know what that number is, but you get that, whatever it is. Now that's a decimal. Is that allowed? Why is that allowed? Because it's on average. Your group of 5 and 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 your group of 5, but on average, that's what it'll come out to be. Okay, see, this next one says with what standard deviation? See, so with what standard deviation? Well, that's going to be my square root of np times 1 minus p, and then you can finish that out tonight. But let's look at question E. Okay, you ready? Here it goes. If we keep picking until we find a lefty, how long do you expect that will take? What kind of problem is that one?
Geometric.
That one is geometric because we're going until we find one. And so the mean for those kinds is what formula? 1 over p, that probability of success. See, there's no n in the formula. You know why there's no n in the formula? They didn't tell me an n. They didn't say out of 5 people or out of 12 people or whatever. Okay, so this would be 1 out of, and I'm looking for lefties, so that's the 0.13 lefties, and so on. Okay, and you can do 17. Let's go back up to the previous page. Let's go to problem number 11 on the previous page. This is the ones that say only 4% of people have type AB blood. Let's read the first question. It says, on average, how many donors must be checked to find someone with type AB blood? Is that a set number of people, or is that a go until you find one? Go until you find one. So is that binomial or geometric?
Geometric.
Geometric. So that's going to be, on average, I need to do 1 over p to find one of the AB. So it's 1 over the probability of AB. Okay. And so, we've left several blank. So this homework is very incomplete. I've just given you hints and guidelines throughout the whole thing. So your assignment is to go through and finish all the little pieces that are missing on pages 47 to 50. But I think I've given you enough support that you can follow what's going on now.